Chapter 14, Temperature and Heat Transfer. This lecture will help you understand change of phase and heat pumps. Matter exists in three common phases: solid, liquid, and gas. A fourth phase of matter is called a plasma. When matter changes from one phase to another, energy is transferred. Energy must be absorbed when a change of phase is from a solid to a liquid to a gas, and energy must be released when a change of phase is from a gas to a liquid to a solid. Evaporation is a change of phase from a liquid to a gas. Molecules in liquid move randomly at various speeds, continually colliding with one another. Sometimes molecules gain kinetic energy, with others lose kinetic energy during collision. Some energetic molecules escape from the liquid and become a gas. Average kinetic energy of the remaining molecules of the liquid decreases, resulting in cooler water. Pigs have no sweat glands and therefore cannot cool by evaporation of perspiration. Instead, they wallow in mud to cool themselves. Sublimation is a form of phase change where the material goes directly from solid to gas. Examples are dry ice, which is solid carbon dioxide molecules, mothballs, and frozen water in winter. Condensation process is a change of phase from a gas to a liquid. Condensation is the opposite of evaporation. Gas molecules near a liquid surface are attracted to the liquid. They strike the surface and lose kinetic energy, becoming part of the liquid, and release heat. If you're chilly outside the shower stall, step back inside and be warmed by the condensation of the excess water vapor in the shower. Evaporation cools you, condensation warms you. The toy drinking bird operates by the evaporation of dichloromethane inside its body and by the evaporation of water from the outer surface of its head. The lower body contains liquid dichloromethane, which evaporates at room temperature. The dichloromethane vapor creates pressure, forcing the liquid dichloromethane up the tube, which raises the center of gravity, and the bird tips over. The water evaporates, taking heat away from the bird, causing the dichloromethane to condense. The condensed dichloromethane runs back to the body, restoring the center of gravity, and the bird tips. Each pivot wets the head, and the cycle repeats. The boiling process is rapid evaporation occurring beneath the surface of a liquid. Evaporation beneath the surface forms vapor bubbles. As the bubbles rise to the surface, if the vapor pressure in the bubble is less than the surrounding pressure, then the bubbles collapse. Hence, bubbles don't form at temperatures below boiling point when vapor pressure is insufficient. Boiling is heating the water from below, warming it, and cooling the water from above. In a pressure cooker, the tight lid holds the pressurized vapor above the water surface, which inhibits boiling. In this way, the boiling point of water is greater than 100 degrees Celsius. In a mixture of ice and water at 0 degrees Celsius, ice crystals gain and lose water molecules at the same rate. The ice and water are in thermal equilibrium. This gaining and losing process is inhibited when salt is added to the water. Then, with fewer water molecules at the interface, fewer enter the ice. More of the water stays liquid. Heat of fusion is the heat associated with the phase change of a solid to a liquid or a liquid to a solid. It only depends on the mass of the material and the heat of fusion constant of the material. Water is 80 calories per gram. Heat of vaporization is the heat associated with the phase change from liquid to gas or gas to liquid. It only depends on the mass of the material and the heat of vaporization constant of the material. For water, 540 calories per gram. This table from Appendix C shows values of melting point, boiling point specific heat, heat of fusion, and heat of vaporization for various materials. Refer to it when doing many of these problems. The figure shows the amount of heat energy needed to convert 1 kilogram of ice at minus 20 degrees Celsius to steam at 120 degrees Celsius. There are 5 steps to the process. First, the ice must be warmed to 0 degrees Celsius. This takes 42,000 joules. Then, at 0 degrees Celsius, all the ice must be melted. This takes 335,000 joules of energy. Once all the ice is melted, it can then be warmed to the boiling point at 100 degrees Celsius, which takes another 419,000 joules of energy. To convert the 1 kilogram of water to 1 kilogram of steam, all at 100 degrees Celsius, takes an additional 1,260,000 joules of energy. The final step warms the steam from 100 degrees Celsius to 120 degrees Celsius, which takes an additional 40,000 joules. The total process from minus 20 degrees ice to 120 degrees steam took 2,677,000 joules of energy. The same process for 1 gram of ice takes 740 calories. Ten grams of ice at 0 degrees Celsius converted to steam at 100 degrees Celsius. How much energy does it take? The first step of the process takes 10 grams of ice and converts it to water at 0 degrees Celsius. We use the mass and latent heat of fusion of the ice. In the solution, the total amount of heat is 800 calories. The second step of the process heats the 10 grams of water from 0 degrees Celsius to the boiling point at 100 degrees Celsius. We use the mass and latent heat of vaporization of the ice. The total amount of heat required is 1,000 calories. The final step of the process converts the 10 grams of liquid to steam at 100 degrees Celsius. We use the mass and latent heat of vaporization of the water, and we get the amount of heat needed is 5,400 calories. Finally, we add the heat required for each of the 3 steps and find it takes 7,200 calories to convert 10 grams of ice at 0 degrees to 100 degrees steam. Left to themselves, systems show that heat flows from a hot object to a cold object. Heat does not flow naturally from cold to hot. A heat pump is a device that warms or cools by transferring heat from a lower temperature source to a higher temperature source or vice versa. It is often used for heating in the winter and cooling in the summer. By doing work, heat can be made to flow from cold to hot. The heat pump process being used as a heater goes as follows. The refrigerant enters the evaporator at a pressure such that its boiling point temperature is less than the outside temperature. It evaporates and exits as a vapor, having absorbed energy from outdoor air. Compression elevates the pressure, the temperature, and the dew point of the refrigerant. The refrigerant gives up most of its absorbed energy to the interior air in a condenser. Refrigerant exits the condenser as a cool liquid. The pressure, temperature, and boiling point are suddenly reduced by the expansion value, and the refrigerant is ready to return to the evaporator. The following are a set of problems for you to work on. Pause the video to give yourself time to work on the problems. Use the formula Q equals Cm delta T to find how many calories are required to raise the temperature of 34 grams of water from 20 degrees Celsius to 34 degrees Celsius. Use C as 1 calorie per gram degree Celsius. Pause the video to work on the problem. The answer is 408 calories. Use the formula Q equals Cm delta T to find the heat required to raise the temperature of 0.022 kilograms of water from 22 degrees Celsius to 33 degrees Celsius. Use the specific heat of water as 4,190 joules per kilogram degree Celsius. Pause the video to work on the problem. The answer is 1,000 joules to two significant figures. Express the thermal energy of 300 calories in joules. Pause the video to work on the problem. To two significant figures, it is 1,300 joules. Burning a 0.6 gram peanut beneath 40 grams of water increases the temperature from 22 degrees to 58 degrees Celsius. The specific heat capacity of water is 1 calorie per gram degree Celsius. Assuming 44% efficiency, find the peanut's food value. And B, find the food value in calories per gram. Pause the video to work on the problem. To two significant figures, the food value is 3.3 food calories. We divide it by 0.44 to account for the fact that only 44% of the food value went into raising the heat, the temperature of the water. The food value per gram is 5.5 food calories per gram. Use the formula Q equals Cm delta T to find the final temperature of 50 grams of water initially at 22 degrees when 500 calories of heat is applied. Pause the video to work on the problem. The basic equation is the specific heat formula. The basic equation must be rearranged to solve for the final temperature. Substituting what we know, the final temperature is 32 degrees Celsius. The 70-liter steel gas tank of a car is filled to the top with gasoline at 20 degrees Celsius. The car sits in the sun and the tank reaches a temperature of 40 degrees Celsius, 104 degrees Fahrenheit. How much gasoline do you expect to overflow from the tank? Pause the video to work on the problem. Both the tank and the gasoline expand, but at different amounts. If the gasoline expands more than the steel, then some will overflow. The difference in the change of the volumes is the amount of the overflow. The basic equations are the volume expansion of liquid and the volume expansion of a solid. The working equation is the difference in expansion of the gasoline and steel. The initial volume and the change in temperature is the same for both the gasoline and the steel. The volume expansion coefficient of the gasoline is 950 times 10 to the minus 6 per degree Celsius, and the linear expansion coefficient of the steel is 13 times 10 to the minus 6 per degree Celsius. Using our data, the amount of the spill is 1.28 liters. Your assignments are to read Chapter 14 in the textbook. Your homework assignments are due April 27th.